Assalamu alaikum dear students. I am Muhammad Mojammal Hussain. Now I am going to demonstrate the experiment of EEE 4604. The experiment number is 3, and today our experiment is construction and study of digital to analog converter, that means DAC, using LM741. So LM741 is called the op-amp. Okay, so here we can see the components. So in this experiment we need 10K resistor. So this is the 10K resistor over there, and IC LM741. So this is the IC LM741 and the jumper. So those things actually we gonna use in our experiment. So there's a breadboard, so you already know what is breadboard, multimeter, and the trainer kit or the DC power supply. Okay, so let's have some introduction with the multimeter. So this is our multimeter. You can see this is the multimeter. So this is the off condition and this is the voltage. So if you want to measure the voltage, then we have to choose this portion. So this is the DC and this is the AC. So how to change the DC to AC or AC to DC? So by pressing this one, we move from DC to AC and as well as AC to DC. So this is the resistor portion. By using this portion we can measure the resistance. Okay, so this is the introduction of the multimeter. So now we have to go through our circuit. So there's a task number 1 and the task number 2. So firstly we are going to the task number 1. So this is the task number 1, DAC, and as you can see, this is the pin layout of LM741, that means op-amp 741. Okay, so see here is the 3 is the non-inverting point, 2 is the inverting point, and 7 is the plus VCC. That means it will connect with the plus 15 volt of our breadboard, and this is the minus voltage. I mean, this one will be connected with the minus 15 volt. So now we go through this one. See, this is the op-amp 741. So there's the 8 pin over there, and this is the circuit. So this circuit we have to construct. See, this is the plus 3 is connected with the ground. 7 pin number 7 plus VCC. So this is the pin number 7 plus VCC is connected with the plus 15 volt, minus VCC it will connect with the minus 15 volt, and this one is connected with the number 2 through a 10K resistor, and there is a 5 volt over there. So this is our circuit. So I am constructing this circuit in the breadboard. So this is the R1 and this is the R2, and now we are plotting the R3. So this one is the R3, and R1, R2 and R3 are connected with the number 2 pin. So here you can see R1, R2 and R3 it connected with the pin number 2 of the op-amp, and now here is connected with the this one is connected to the number 6. So this is the 6. There's a 3, 1, 2, 3. 3 is connected to the ground. So this is the ground. 7 is connected to the plus VCC. 1, 2, 3, 4, 5, 6, 7. 7 is connected to the plus VCC. That means plus 15 volt. And 4 is connected to the minus VCC. 1, 2, 3, 4. Working on the minus VCC. So there's a 5 volt over there, so this is the 5 volt. So 1 2 3 4 5 6 7 8 up to 20, that's 2 points at the same point. So 5 volt I'm placing here. So from that point I connect the 5 over there, and I also connect another 5 volt at this point. So our circuit is almost complete now. So now we have to measure the output voltage from pin number 6 to ground. From pin number 6 to ground, I repeat, we have to now measure the voltage, I mean the output voltage from pin number 6 to ground. That means we have to check. Now the circuit is on. So first you have to check the voltage. First you have to check the input voltages. You see, this is the voltage and this is the DC, because this experiment is on DC. See, this is a 5 volt. So now I have to check the plus VCC. So this is a 15.20, it's also okay. And now this is the minus VCC, 15.88. So by this procedure we check the input voltages. So now we have to check the output voltage. So actually we have to measure the output voltage from pin number 6 to ground. Remember it, pin number 6 to ground, pin number 6 to ground. So there is a data table. So there is a data table. This data table actually the same thing. This is the formula. See, this is the formula for measuring the P out, and this is the ultimate result of this experiment. So there is a number 8 observation, V1, V2, V3. That means we are applying the voltage, this one, V1, V2, V3, V1, V2, V3. So this is our calculated value, these are our practical value. Calculated value, we get the calculated value from using this formula, and we get the practical value by measuring the output voltage of this one and this one. So this is our data table.